Okay, so now maybe before we continue with more attribute stuff, let's diverge a little bit and talk a little bit about some more sub-level stuff that you kind of need to know. So what we're gonna do is we're gonna build a very simple table, which is also going to use the copy to points and stuff that we used in the previous episode. Let's make a geometry node. Dive in here. All right, so how would we start making a table? We want it to be a procedural table, right? So let's think about this for a little bit. A table. What's the shape? It's basically a square. So maybe start with a grid. So I guess this would be a good shape for a grid. And we only want it to be 2 by 2. Let's put 2 by 2. And why do we want it to be 2 by 2? Well, you can see I have these points here. And coincidentally, these are 4 points. So how many legs does the table have? Well, it has 4. All right, so what we could do is we could copy something to these legs to make it a table. Well, what do we want to copy to it? Because we want some control, of course, over like how does our table look? Does it like have square square legs or round legs? So maybe to just like have it be as flexible as possible, let's say we want to have the control for that. So let's copy a line to it, because with this line we can later generate a shape. So let's put a line. Let's type line, and we see we have a line. Now let's just type copy to point. Copy to point. Put a target point, will be our grid, because this has points, so it doesn't necessarily need to be scatter points. It will just copy it to the points that we have on our geometry. And then let's put in the line. And you can see it sort of puts it in a random direction. That's because in order to perfectly say that which direction do we want to copy, you need some more attributes as well. I'm not going to go into that a little bit more. Let's for now just fix this by just giving it a different direction. So let's put the direction of the legs into the Z scale, and let's put it to -1, because we want them to be pointing downwards. So you can see we can now move them sort of up. All right. So we have this grid, which will be the base of our table. Now let's say we want some control to move this table up, to determine the height of the table. So how would we do that? We would probably put down a transform. So put down transform. And with transform, like we did before, if we press enter in the viewport, we can move this up. So now maybe what we want to do is we want to sort of be able to link up how much we're moving this up to the length of our line, because the line will be moving downwards. So how can we do that? Well, in Houdini, you can sort of link up channels. So what we can do is so let's move this up a little bit. If we right click on a channel and then can we say copy parameter. So click on that. Then if we go in our line, you can see the line has a length attribute. If we right click in this, you can either paste values or you can paste relative references. So if I do that, you can see what it does. It puts CH, stands for channel, and then it will make a path. So this is a string. Like before, string is a set of letters, for example, a file path. So it's between quotation marks. I mean, it will be a string. And it will, so with the 2 dots, it will say that, okay, it's looking for something inside this network. If I were to put ... slash and then again ... slash, it will go up 1 level. You can see it's geo. So it will look for something inside of here. It's looking for transform 1. So that's this node. And then it's looking for ty. And all of these things here have a basically have a parameter that they can reference. So it's kind of like an attribute. So this every single thing of these things has their own. It's a parameter. It's not an attribute, but it can reference that value just like an attribute. So you can see if you hover over this, you can see parameters tx, ty, tz. So this will reference ty. And you just did that by relative references. So we didn't even need to do it ourselves. Anyway, so right now you can see that now it makes the length equal to the height that we put in here. And because this is set negative, it will just like move downwards. So if I move up my table, you can see this will basically just move to wherever our table is. All right. So far so good. So now let's think like how should we continue this? So maybe first we kind of want our table to not be completely flat. So maybe do poly extrude. And let's extrude our table top a little bit like this, and let's put output back. So we also have a back, because else the back will be open. So now we don't have a flat table. And remember, Houdini works non-linearly, like I showed you before. So if we put down a merge, and then we can merge our copy to points and our poly extrude together. So now we can see our lines and our table. And if we just move this up and down, you can see, so this transform is feeding both into the line and into the extrude, and then merging it back together. Of course, this is not yet what we want, but like just to prove a point of how this works. So let's make it a little bit lower. And let's disconnect this one again. So because we probably want to do some more work on our, basically on our lines. And maybe we kind of want to save our file as well. So just save is just Control S, or file, save project, save as. I'm just going to call this table. Right, press accept. So now I saved it. All right, so there's multiple ways we could go about making these legs. So I'm just going to show you a couple of different ways, because in Houdini there's always 1001 ways to do anything. So one way would be, for example, to do polywire. So if I type polywire, what polywire will do is it will create a basically a shape around our, well, so it will mesh our lines. So you can see we have a thickness, we have divisions. So we have basically, our okay, so we could make it round, and if we merge it back in, you can see we just have it like that. So probably not perfect, because as you can see, this might not be the best way to do it, because you can see we kind of need to change this a little bit, because right now it's not really, I mean, it's not a square. So maybe polywire wouldn't be the best way to do this. Let's take another approach. So maybe what we want to do is maybe we want to use a sweep. Let's put a sweep and put it underneath the line here. And then we want a cross section, and let's make a circle. Put circle under the sweep. Let's make it a polygon. And you can see right now it's already something is happening. And then now if we highlight it, right, now you can see it actually created circles here. And now we have control on our thing here. So how thick are they going to be? How many divisions? So if you put it to 4, well, it's still not perfect because it's still rotated. But on this thing, we're going to have a rotation. So if we put it to 45 degrees, so that's not really that great. Probably want to have it be, probably want to rotate it in another axis. No, not that one either. Probably, yeah, okay, perfect. So we wanted to rotate in a Z position. So basically what we're doing here is we're just generating this thing over here. And then maybe we want to do is polyfill this. So polyfill. So what polyfill will do is we'll just fill the sides. And then we're copying it to our table. And then if we merge it back in, that's already starting to look a little bit better. So you can see it's blue right now. This is because they are probably, the normals are pointing inwards. So maybe what we want to do is we put down a reverse over there. And now you can see it's looking, this is looking better. So if it's blue, generally it's the normals pointing inwards. All right, so this is looking better, but you can see this is copied to the center of our thing here. So maybe we want something to be able to solve that it's not going to be exactly on the point here, but maybe slightly inset. So how could we do this? I want you to think for that a little bit by yourself, a couple of seconds. Maybe try it by yourself and like pause the video. And well, okay, we're back. Now I'm going to show you how you're going to do it. All right, so what you can do is, again, remember Houdini is non-linear. We can do another transform over here. And we could say, okay, we want to transform this downwards. But we don't want to transform it in the Y position, of course. So if we're going to do a linear transform here, this like the uniform scale is not going to work. What we could say is that we only want to scale it down on the X and the Z. So we could say maybe 0.9 here, 0.9 here. All right, so now it's moved inwards. And now if we change the size of our grid, you can see everything is moving along as we expect it to, because this whole thing is linked to the grid here. And again, we can just transform this upwards. We can scale it like this. We can scale it like this. So we have this very nice sort of procedural table. Now these are, maybe we want to have some smoother edges. And of course, these are still, like, this is not part of the mesh. This is just sort of separately connected. So how could we solve this? Well, instead of merging, maybe we want to Boolean this. And by the way, in this case, you don't want to use back an instance for this. We just like this because we want this to stay geometry, because we're like modeling on this thing, right? So maybe we want to do is we want to Boolean these two meshes together. So put it, and then instead of subtracting, let's put it to union. So now you can see it's adding it into the actual mesh. All right. So now let's maybe say we want to sort of round our edges of our table. Well, we can of course do that with a bevel, but maybe we don't want to bevel every edge. We don't want to bevel this weird little edge that we have here, for example. So what we could, for example, do is, like, remember when I showed you the group node, that it has like a whole bunch of options. Well, if I put down a group node here, and let's put it to edges. We want to group edges. You can see right now it's grouping every edge. Let's disable that. Maybe call this bevel group. So if you enable include by edges, you get a whole bunch of options for including your edges. So if we put minimum edge angle, it's going to check for the minimum angle that an edge needs to be. And of course, like this doesn't really have an angular thing. So if this is too low, so it will now it will, like if we put it to 90, then we can be sure that it sort of should work all of the time. If we put it to 90, it will just group everything at an angle of 90 degrees. And again, we can use these groups inside of other nodes. So if we type bevel, put it down, then we can put this on the bevel group and then maybe increase our bevel. And then put this to, it's set to around, and we can have some more divisions maybe. Put 2 divisions. See, now we get these nice round edges. So now we have these nice round edges of our table, and the downside here is looking a little bit weird. So maybe what we want to do is we put a divide. I want to put it before here. This will just add these extra lines, so we get sort of a more, so we at least get like, so it will just divide our stuff. Right, so put poly bevel. So now we have a table that we can press transform, enter, and we can see we can move it up, we can move it down, we can scale it. We have a nice, so it might break at some points because of the bevel thing. So now we have this table. Now we also kind of want to make a chair. So I want to challenge you to try to make a chair yourself without me explaining anything. And then in the next video, we're going to go over how you could build a chair. But really try it for yourself first, just with these things that I've showed you so far. Just see how far you can get. And I mean, if you run into trouble, that's fine. In the next video, I'm going to show you how you could make a chair. And there's 1001 ways to make a chair, but this will be a way to do it.